Good afternoon and welcome to this presentation on successful urban tree plantings. I'm Scott Jensen and will be conducting today's presentation. For more information, please follow us on our social media platforms. We post industry-related news and articles. Also, our website has a wealth of information. Most of today's presentation, you can find the related information directly on our website. You can also reach out directly to me with questions, and I will get you that information as quickly as possible. My contact information will be at the end of this presentation, and you can call or email me. So to give an overview of this presentation, we're going to talk about the use of lightweight expanded shell and how it is used to create an engineered soil to address the challenges with growing and establishing trees in a built environment. Specifically, some of the challenges related to urban tree plantings. We'll discuss the lightweight aggregate manufacturing process and the properties, why it works in this situation. We'll discuss the benefits of having established trees in urbanized areas. We'll also discuss the role of engineered structural soil and its application in tree plantings and establishment. And then we'll look at several successful projects highlighting the use of engineered structural soil. So to start off with, lightweight expanded shell is heated in rotary kilns, and as the material heats up, it expands and vitrifies. So you can see the porosity. It's a high strength, it's lightweight, it's a ceramic aggregate. And it's used in everything from structural lightweight aggregates or structural lightweight concrete as a lightweight aggregate to stormwater management, to geotechnical fill, and obviously today landscape design and specifically urban tree plantings. Some of the properties associated with the lightweight expanded shell, it's half the weight of normal rock, sand, or soil. It is structurally strong. It's a vitrified material. It will not degrade, decompose, or break down. Even in freeze-thaw climates or harsh weather climates, it'll still maintain its structural integrity. It's porous, and you can see from the previous slide the macro and micro pores that make up each individual particle. The material is absorptive. It'll retain water and waterborne nutrients and release it easily as plants need it. A big advantage of the processed lightweight aggregate is the consistency and quality control when it's being processed. Sizing of the aggregate is very similar to traditional gravels and sands. We have a fine graded material as well as a mediums, which is typically in the 3/8 sized material, and then we have a coarse, which is generally 1/2 inch on up. So engineered soils, they can take on a couple of different meanings. Engineered or designed soil media consisting of precise soil components blended to meet specific project design criteria. So these can range from anything from urban tree plantings to creating a soil for bioretention. These types of engineered soils consist of other soil-related components such as compost, sand, the expanded shell, topsoils, peats, there's biochars, all kinds of fertilizer additives. There's all kinds of different things and ways to create an engineered soil specifically to meet a project's criteria. Some of those criteria might include reducing the weight load, such as a rooftop garden, or increasing the drainage, water percolation rates. There might be an issue with compaction where you're trying to limit compaction, such as the case of the sports field. Water storage, longevity, filtration. Engineered soils can improve and treat water, give you a level of filtration. They can be compact or compaction resistant. And then there's other specific criteria that may be important on a particular project. Engineered soils allow you to meet these requirements with a soil blend. Engineered soils have a wide range of application. Obviously today we'll be talking about urban tree plantings, but along those same lines, you can use it to create drivable grass that are suitable for fire lanes or emergency vehicle access or temporary parking, lawn events. They're important in managing stormwater, either as just keeping the water on site or actually treating that water for reuse. Expanded shale and engineered soils have played a long, important role in green roofs and rooftop gardens. And then soil amending and creating root zones for athletic fields. Also, they're used as a granular fill or a drainage material. And additionally, they're used in all kinds of specialty gardens or specialized plantings. So we're going to focus a little bit on urban tree plantings. Specifically, you see these in side streets and sidewalks, usually with tree grates. Also, you'll see them in parking lot islands or courtyards. The thing these all have in common is they're typically surrounded with some kind of hardscape or pavement. Obviously, urban tree plantings have a huge benefit to the community, to our environment. They help with pollutants and fine particulates. They support our local ecosystems and wildlife habitats. They help mitigate stormwater. They absorb rainfall. They provide recreational opportunities with shade. They beautify our communities. They help with noise pollution, stabilize wind. More and more research shows that they have a potential to improve our physical and our mental health. They can provide a sense of security. They help us connect with nature, and they increase the value of our businesses, our homes, our communities. And there's a wealth of other benefits that trees can provide for our community. However, getting those trees to establish and generate those benefits can come with some challenges. A typical soil that a tree on a highly urbanized area that is being planted in will have a soil that looks very much like that picture, where it has a limited amount of natural topsoil or natural soil. It is usually a highly compacted base type construction material. There is limited room for root development. It's very compacted, so it has limited air, water, and nutrient flow. And there can other be challenges with other buried utilities or elements. There could be foreign debris that's in there left over from the construction process, all of which makes it very challenging for a tree to be planted and established and expected to live for a long time. Additionally, there's other challenges that are posed with urban tree plantings. In an area with snow and weather, a lot of times the snow gets pushed into those islands or into those tree grates, where the snow piles up and can damage the tree. It also can cause the de-icing salts to leak out within the root zone. There's examples of kids damaging trees from hanging on or playing them, or being driven over in parking lots, drivers hitting with car doors. And then there's also issues associated with improper maintenance practices. So urban tree plantings, there's research that suggests that the longevity of the tree is directly correlated to the usable amount of quality topsoil or soil for the tree roots to establish in. So the more access it has to a soil volume with adequate flow of air, water, nutrients is going to be essential to this long-term establishment and growth. In these built environments, it's not uncommon to replant the trees every couple of years, as they just don't establish under those conditions. The engineered soil, structural soil, as quite often as it's referred to, can help alleviate and overcome some of those challenges associated with growing trees in a built urban environment. They provide additional usable soil volume. They provide the porosity to ensure that you have adequate flow of air, water, and nutrients. They allow root development and expansion into the root zone. And most importantly, they can support the weight associated with the hardscape or the pavement or pavers, whatever the top layer ends up being. These upfront costs are more often than not paid off fairly quickly with a tree that has a longer lifespan and can provide those benefits that we discussed. So looking at the structural soil, as it consists of a two-part system, a coarse aggregate. In this case, it's a coarse expanded shale aggregate, and that's blended with an amount of natural topsoil. Quite often that aggregate is wetted down so that the soil adheres to it to aid in the compaction and the transport of the structural soil. If you look at the concept behind the structural soil, a lot of people refer to it as a load-bearing lattice system, where the aggregates contacting one another provide the physical stability, the support of the hardscape, and then the soil is allowed to partially fill those voids to give you water retention, to give a place for nutrients to reside. The beneficial microbes and all the biological that comes along with it can reside within that soil volume. Typical structural soil properties for engineered lightweight expanded shale structural soil is usually 80% of the expanded shale amended with 20% of a loam or clay loam type topsoil. And you can see some of the physical properties of it. Typically, you're looking at a loose bulk density of less than 65 pounds compacted in place. You're easily below 90 pounds. You're still getting excellent drainage with water. And you can meet the compaction required by the engineers of having a 90 to 95% compaction. One of the common questions that comes up is how much structural soil is needed. And there's obviously formulas out there, equations that you can use to figure that soil volume based on the projected canopy and trunk size of the attended tree species. However, more often than not, it's more project specific because there's different utilities and site specific constraints that'll ultimately determine what kind of volume there is. Typically, the goal is to have a minimum of a 24-inch depth, but 36 inches is more of a standard, and the widths or the lengths of that are generally starting at about 10 feet diameter and going out as the intended canopy of the tree is predicted. As far as installation goes, the material is placed in lifts, usually not exceeding more than a 12-inch lift. Each lift is compacted to its 90 to 90% compaction maximum density. This is done with a couple of passes using a vibratory plate compactor. The final course may have a leveling course for the pavement depending on the specifications for the project. It's important to remember that with the compaction, it's not necessarily trying to compact it completely as tight as it can be, but more generally wanting to seat the material into place. And that's generally accomplished with just a couple of passes of a plate compactor. Another common question is when the structural soil should be placed, whether it should be placed before the pavement or after. In most cases, the structural soil most likely is going to be placed prior to the concrete or the pavement or the pavers. However, there are instances where, as particularly in parking lot islands, where it might be easier for the contractor to excavate and do the structural soil placement after the pavement has gone in. But generally speaking, it's done before. So looking at some of the projects that have used the structural soil, this particular one is a sidewalk application where the structural soil was placed out to the edge of the roadway at a depth of close to 36 inches and spreading back towards the building. Here's a project, University of Utah, the Stadium Plaza in Salt Lake City. You can see in the picture where the structural soil has been placed around the planters. And these come out, the structural soil is placed around beyond those raised planters. A more of a modified mix was placed in around the trunk of the tree, that had a mixture of topsoil and the structural soil, which is common. This is an application at the Sorensen Rec Center in Harriman Library in Harriman, Utah. You can see also the trees. The structural soil was throughout the area of the plaza where the trees were planted. And this planted along the roadway with the structural soil coming underneath the sidewalk. Federal Courthouse in Salt Lake City. Once again, all this area was placed with the structural soil, the concrete walkway placed over it. Another application in Draper, Utah. 2 specimen trees, were placed. You can see where the concrete and the pavers were placed over the structural soil. This is City Creek Center in Salt Lake City, Utah. This is the Missionary Training Center in Provo, Utah. You can see the trees in the planters had the structural soil underneath that came beyond those planters. And there too, the soil in the planters was a mix of the structural soil with native topsoil type blended material. Example of the trees along a parkway or parking lot right up next in between the buildings. Here's an application for illustration purposes. These trees were small to begin with, but you gives the demonstration of where the structural soil was placed for these particular trees. This is a urban parking lot or a parking lot detail where the structural soil was placed after the pavement. The pavement asphalt was excavated. They placed the material, compacted it in, and placed the trees afterwards. This is on the right. There is an example of a tree that has a planter, quite a large planter surrounding it. This is a more recent picture of the Harriman Town Hall. You can see the outlines of the structural soil going back towards the parking lot edge. And the same thing on this one here. This town hall is an ongoing project. There is other phases you can see to the south of that that'll be going in. This is also another recent photo, shows them putting in the structural soil prior to the placement of the sidewalk. This is the Orem Provo UTA Rapid Bus project. The Health Center Theater. This one is on these couple of trees out front of the building where it was filled in and the concrete placed over those trees. You can also use a suspended type system or a cell system with urban tree plantings and structural soils. The advantage to using these engineered soils in a suspended pavement is that they're typically native soil based. You get more of a natural soil for the trees and the root development. They typically can be amended so that you can improve the soil's physical and biological properties, making them even more favorable for the trees' long-term establishment. And they can also benefit by providing some rain garden or stormwater management in the event of rain. So this is an example of one in Salt Lake City. It's a Silva cell system. This is on South Temple. You can see the cells on the right, an amended topsoil consisting with a expanded shale fines amendment to provide additional porosity to the clay loam that was used, as well as an organic amendment, and some fertilizer that was added to that topsoil was placed into the cells, which provided the support in the rooting zone for the trees, the root development zone, the trees going up to the south temple, both the street and then to the wall. There are obviously other applications where the cantilever system or a cell system can be applied. There's multiple suppliers of those systems now, and that blend of topsoil and expanded shale and compost works really well and provides tremendous results. So just to finish up this presentation on urban tree plantings, the takeaway from today's presentation is that trees are a critical part of our community. Trees need an adequate and quality soil to survive long term, and structural soils or engineered soils can provide that needed soil structure. As I mentioned up front, be sure to follow us on Facebook and to check out our website. We have a lot of information there regarding the applications, examples of projects we've done with regards to urban tree plantings. Please give me a call at my phone number or shoot me an email, and I'd be happy to get back with you with additional information. Appreciate you taking the time to check out this presentation on the use of Ute-Lite expanded shale in structural soil and urban tree applications. Look forward to hearing from you and working with you. Thank you.